Welcome back to another video. It's Dr. Tarcia Hubert here, and in this video we're going to be talking about finding trigonometric function values using reference angles. Alrighty, so I know you might be wondering, what exactly is a reference angle? Well, a reference angle of an angle is an angle that's formed by taking the positive acute angle between that angle and the terminal side of that angle in the x-axis, my bad. So if you have an angle, regardless of where it is, every angle has a reference angle. If you take the terminal side of that angle and you measure the angle that is formed from going from the terminal side to the x-axis, that is your reference angle, okay? Now, if that don't make sense in words, let me show you, because I am a visual learner myself, so hopefully these images will help you. So we're going to look at an angle in each quadrant. In this particular picture, this angle, the blue side is the terminal side. The angle is theta, represented in green. And this angle is in quadrant 1, okay? I'm trying to get my laser pointer here. Okay, so here's the angle from here to here. All right, the reference angle is the angle that's found from going on the terminal side to the x-axis. So in this case, in quadrant 1, the reference angle, which we use theta prime, this little line right here means prime. We use theta prime to denote reference angle. It's actually the same as the angle itself. So the reference angle is equal to the angle itself in quadrant 1. That's the only quadrant where that happens, okay? Let's look at an angle in quadrant 2. So here's an angle in quadrant 2, the green angle. That's our angle theta. Now, if we want to know what is the reference angle of angle theta, then we would have to find the angle that goes from the terminal side to the x-axis. So it'll be this angle here. This angle will be our reference angle, and that's called theta prime. And we will find the measure of this angle by taking 180, because remember from there to there is 180, and subtracting our angle theta from it. So that's what we have here. This is how you find the reference angle if the angle falls in quadrant 2. You would do 180 minus the angle that you're trying to find the reference angle for, and it will give you this angle here. That's the reference angle in quadrant 2. All right, here we have an angle in quadrant 3. So it's this green angle here. That's our theta. And then our reference angle, again, will be found from the terminal side, the angle that's formed from taking the terminal side to the x-axis. So it's this angle right here. This is our reference angle. And so now if it's in the third quadrant, if we want to find that reference angle, we will have to take this angle and subtract 180 from it, because remember from here to here is 180. So if we take this full angle, subtract the 180 from it, it leaves us with this amount right here. So this is how you find the reference angle if an angle falls in the third quadrant, okay? You do the angle minus 180. And then lastly, if the angle falls in the fourth quadrant, so we have this angle here in the green, theta, and we want to find the reference angle. So again, the reference angle is found from taking the terminal side, the angle that's formed from going to the terminal side to the x-axis. So it's this angle here. This is our reference angle, theta prime. And so in this case, if we want to find the reference angle, we will take 360, which is 1/4 rotation, and subtract that angle theta from it to give us this remaining amount. So if you want to find the reference angle in quadrant 4, you would do 360 minus that angle, okay? So that is the reference angle. It's the angle that's formed from the terminal side to the x-axis, and you can find the reference angle using different formulas depending on which quadrant it falls in. So let's look at some examples. So for these examples, example 1, it has 2 parts. We want to find the reference angle for each of these, okay? So I am going to get my pen here, and I'm going to make sure it's black. And so for this first one, 218 degrees. So if we just think about 218, I'm going to do a quick sketch here. So we know from here to here is 180. So 218 will fall somewhere in the third quadrant. And so if we were to go back and look at quadrant 3, how you find the reference angle in quadrant 3 is you do the angle minus 180. So I would do 218 minus 180, and that would give me theta prime. Theta prime. And so that would give me theta prime, which is our reference angle, to be 38 degrees. So our reference angle for 218 degrees would be 38 degrees, okay? Now for this next one, 1387 or 1387 degrees, this is an angle that is bigger than 360, So in order to figure out what quadrant it falls in, we will first have to find a coterminal angle. And so remember, to find the coterminal angle, you just keep subtracting 360 until you get an angle that's between 0 and 360. And so in this case, you end up subtracting 360 3 times to get an angle between 0 and 360. So if I subtract 360, keep subtracting 360, then I finally get to 307. So a coterminal angle to 1,387 degrees is the angle that is 307 degrees. And so now if I do a quick sketch of 307 degrees, I know that this is 180. I know here is 270. So 307 has to be somewhere here in the fourth quadrant. So this is my angle theta. And so if I go back to quadrant 4, this is how you find the reference angle. You do 360 minus that angle. Y'all see that here? So I'm going to do 360 minus 307, and that is going to give me my theta prime. So theta prime is going to be equal to 53 degrees. So the reference angle for 1,387 degrees is 53 degrees, okay? So that is how you find the reference angle. And so we want to know how to find the reference angle because we can also find trigonometric function values if we know the reference angle of an angle, because they have the same trigonometric function values if they have the same reference angle, just different signs. So let me show you what I'm talking about. And this is the process that we will go through to find it, okay? So first of all, you have to look at the angle and decide if the angle is either bigger than 360 or less than 0. If you don't have an angle that's between 0 and 360, then you first have to find the coterminal angle, which is what we just did in the last problem. So once you find the coterminal angle, that's if it's not between 0 and 360, then you find the reference angle. So once you find the reference angle, then you use the trigonometric function values of that reference angle. They'll share the same trigonometric function values. The only thing is that the signs may be different, because reference angles are acute angles. Then that means when you take the trigonometric function values of the reference angles, you're always going to get positive answers. But depending on which quadrant your angle falls in, your sign will change. So step 4 is actually determine the correct signs for the values that you found in step 3. Okay, so let's look at that. How to do that, how to use that, okay? So we want to find the 6 trigonometric function values for a 210 degree angle. So 210 degrees is between 0 and 360. So we don't have to find a coterminal angle, so we can skip step 1. So then step 2 is we want to find the reference angle. Alrighty, and so the reference angle is going to be found depending on what quadrant this is in. So again, from here to here is 180. So 210 will fall in this quadrant somewhere, which is quadrant 3. So this is theta. It's approximately 210 degrees. To find theta prime, which is the reference angle, in quadrant 3, you would do 210 minus 180. And so in this case, our reference angle is 30 degrees. So now we will just find the 6 trigonometric values for 30 degrees. However, the signs may differ. So I want to find the sine of 30, which is going to be the same as the sine of 210. It's just you have to check the sign, the plus or minus sign. I'm going to find the cosine of 210 degrees, which is going to be the same as the sine of 30. The tangent of 210 degrees. Not necessarily exactly the same. It's going to have the same value, but the sign may be different, okay? We're going to find the cosecant, the secant of 210 degrees, and also the cotangent of 210 degrees. So we want to find those 6 trigonometric function values. So starting with the sine. So we know that the sine of 30 degrees is, the sine of 30 degrees is 1/2. Okay, so the sine of 30 degrees is 1/2. However, sine refers to the y value, right? Remember that was y over r. And in quadrant 3, x and y are both negative. So if that's y over r, remember r is always positive, then in the third quadrant, the sign would be negative. That's because your y is negative in the third quadrant, okay? We also know that the cosine of 30 is square root of 3 over 2. And remember, cosine of 210 is going to be the same as the cosine of 30 because 30 degrees is the reference angle for 210 degrees. So now we just have to ask ourselves, cosine deals with which value? Cosine is x over r. R is always positive, but in the third quadrant, x is negative. So since x is negative and r is positive, that means our cosine will also be negative. So we have sine is negative 1/2. Sine of 210 is negative 1/2. Cosine of 210 is negative square root of 3 over 2. And then we also know that the tangent of 30 degrees is the square root of 3 over 3. All right, we did these in the last video. You should have put these in the chart, and you should also work on remembering these, okay? You need to know these because we will use these over and over again. And so tangent is y over x, and since our y is negative and our x is negative, when you divide a negative by a negative, it'll be a positive. So your tangent will remain positive square root of 3 over 3. And now I wrote these so that the reciprocal is right across from them. So the reciprocal of sine would be negative 2. The reciprocal of cosine of 210 would be 2 over square root of 3. Or if you remember, you rationalize the denominator and it becomes negative 2 square roots of 3 over 3. And then the reciprocal of tangent ends up being the square root of 3. Alrighty, so you end up having, or the cotangent of 30 degrees is the square root of 3. So if you remember that, you can say that the cotangent of 210 is also the same as the sine of 30 degrees. I mean, not the sine, the cotangent of 30 degrees. Alrighty, so hopefully I said all of this correctly. The sine of 210 is the same as the sine of 30 degrees, except the sine, the SIGN sign, changes. The cosine of 210 is the same as the cosine of 30 degrees, except the SIGN sign changes. The tangent of 210 is exactly the same as the tangent of 30. Cotangent of 210 is the same as the sine of 30. Secant of 210 is the same as the secant of 30, but the sign changes. And same with the cosecant. Cosecant of 210 degrees is the same as the cosecant of 30 degrees, but the sign changes, okay? So we went through those 4 steps. We didn't have to do step 1. We did step 2, found the reference angle, and then step 3, we found all the trigonometric values of 30 degrees, and then step 4, we actually changed the signs of each. But we actually merged step 3 and 4 together, okay? Let's look at another example. We want to find the cosine of negative 240 degrees. So now this angle is not between 0 and 360. So the first thing we would want to do is find the coterminal angle. And remember, if you have a number bigger than 360, you subtract 360 to get the coterminal angle. But if you have a number less than 0, you add 360 to get the coterminal angle. And so the coterminal angle would be 120 degrees. That is your coterminal angle. Now you find the reference angle. So 120 degrees is going to be in quadrant 2. 120 is going to fall over here somewhere. That's theta. And if that's in quadrant 2, then you find the reference angle theta prime by doing 180 minus 120, which gives you 60 degrees. So what that means is that the cosine of negative 240 degrees is going to be equal to the cosine of 60 degrees. However, you have to consider the sign. So in quadrant 2, your x is negative and your y is positive. Well, cosine deals with x. It's x over r. So x is negative, r is positive. So your cosine would be negative. All right. And so the question is, what is the cosine of 60 degrees? The cosine of 60 degrees is 1/2, but it's negative 1/2 because it's in quadrant 2. So that is how you will find the cosine of negative 240 degrees. If you have any questions about this problem or the last example that I just worked, then go ahead and put them in the comments. Okay, I want you to try this problem. I want you to see if you can find the tangent of 675 degrees. Go ahead and pause the video for a moment and find the tangent of 675 degrees. Okay, so the first thing you should have done for this problem is you should have found the coterminal angle to 675. So that includes subtracting 360 to find an angle that's between 0 and 360 degrees. So if you subtract 360, you get 315 degrees. So your coterminal angle is 315 degrees. That means 675 and 315 share the same terminal side. So now you need to find the reference angle. And 315 degrees is in quadrant 4. So to find the reference angle, you would do 360 minus 315, which would give you 45 degrees. So the reference angle to 315, which is also the same as the reference angle to 675, is 45 degrees. And so the tangent of 675 is going to be equal to the tangent of 45 degrees. However, it's in quadrant 4, so you have to check to see what would the sign of it be. So in quadrant 4, your x is positive and your y is negative. And so since tangent is y over x, that will be a negative over a positive, which will make that a negative. And tangent of 45 degrees is 1. So your answer would be -1. Did you get that? Hopefully you got that. If you didn't, make sure you understand where you made your error. And then if you have any questions at all about this problem, you can put them in the comments below as well. All right, let's do one last example. We want to evaluate the cosine of 120 degrees plus 2 sine of 60 degrees minus tangent square of 30 degrees. And actually, I have a typo in this problem. This is it's supposed to say 2 sine square of 60 degrees. Alrighty, so just add that square right there. And what we want to do is we want to evaluate this. So we first have to find the cosine of 120. 120 degrees is in the second quadrant. So if you wanted to find a reference angle, you would do 180 minus 120, which is 60 degrees. And you would find the cosine of 60. The cosine of 60 degrees is 1/2. No, the cosine of 60, is 1/2. And so it would be 1/2. However, you will have to consider the sign of it. In the second quadrant, the cosine is negative. So if you consider the sign of cosine in the second quadrant, because it deals with x and your x is negative, then your cosine will be negative. So we have -1/2 right there. All right, now we want to figure out what is the sine of 60 degrees. So 60 degrees we know is in the first quadrant. We also know that the cosine of 60 we just said was 1/2. So that means the sine of it is square root of 3/2. And remember, I added that square in there, so we are squaring the square root of 3/2. And then for the tangent of 30 degrees, the tangent of 30 degrees is the square root of 3/3. And we are squaring that as well, okay? So we have -1/2 plus 2 times the square root of 3/2 squared. If you square the square root of 3, you get 3. And if you square 2, you get 4. And then minus the square root of 3/3 squared. Square root of 3 squared is 3. And 3 squared is 9. And so now we want to simplify this. We get -1/2 plus 2 times 3 is 6. 6 divided by 4 reduces to 3/2. And then 3/9 reduces to 1/3. All right, 1/2 plus 3/2 is 2/2, which is 1. So you end up with 1 minus 1/3, which is equal to 2/3. So all of this evaluates into 2/3. Okay, so we found each of these measures individually: cosine of 120, sine of 60, and tangent of 30. We squared these, the sine of 60, and we squared the tangent of 30 degrees. And then we also multiplied this one by 2, and we simplified and combined our fractions. And we got our final answer to be 2/3. Alrighty. If you have any questions about how we evaluated this, or any questions about anything in this video, please don't hesitate to write them in the comments below or email me. I will respond to your questions. Thanks for watching, and if you haven't already, go ahead and hit that subscribe button. I will see you all in the next video. Thank you.